Hi all, welcome to our new video. In this episode, we are going to talk about the revolutionary technology, blockchain. But what exactly is blockchain? Think of it as a traditional ledger, like the ones used in accounting. Transactions are recorded chronologically, but here's where things get interesting. In a traditional ledger, all the information is usually stored in one place, often at the company's main office. Because it's owned and managed by just one entity, it's pretty straightforward for them to make adjustments that align with their own interests. Blockchain. It's a decentralized and distributed ledger system. Each transaction is shared with all nodes in its chain. Nodes are essentially computers or devices connected to the blockchain network, and they all contain a copy of the entire chain of transactions. Any attempt to tamper with information in one node would indeed get reflected in all the other nodes. This consensus mechanism ensures that the data remains consistent and trustworthy across the entire network. Let's simplify this complex concept with a relatable scenario. Four friends are planning a vacation trip, and they've decided to adopt a blockchain-like system to track their expenses. As the initial step, Rick creates a shared ledger on his smartphone. He then generates a block containing crucial information, such as each member's contribution and the time of block creation. In blockchain terminology, this block is known as the Genesis block, the foundation of the blockchain.
Throughout the trip, whenever someone spends money, a new block is created to record the transaction. For example, when Rick spends $50 on dinner, a new block will create it and link to the previous block. Similarly, a new block is created for Mick on fuel, Steve on snacks, and John on activities. Each block linked to the previous one, forming a chain. Let's see how this works in blockchain. Blocks in a blockchain are linked through cryptographic hashing functions, creating a unique hash for each block based on its content. These hashes essentially act as digital fingerprints or secret passwords, linking each block to the previous one. Even a minor change in the block's content would result in an entirely different hash. Thus, the alteration would indeed affect the cryptographic link to the subsequent block. Once a block is added to the blockchain, it's exceedingly difficult to alter anything within it without changing its hash. However, it's not technically impossible to alter the content of a block. It's more about the practical computational infeasibility of recalculating the hashes of subsequent blocks to cover up any changes made. The decentralized nature of the blockchain also means that other nodes in the network would reject any altered block that doesn't match the consensus. Returning to our example, when Rick adds $50 for dinner, this transaction notifies all others. It only becomes part of the ledger when all three others approve the transaction. Once added, the transaction cannot be edited. Similarly, if John attempts to add a transaction claiming he spent $50 on activities, it will be rejected as the previous link indicates each member's balance, and John only had $40 on hand.
In essence, the Friends Ledger system mimics the blockchain, illustrating how transactions are securely recorded, linked, and maintained in an immutable sequence. While the trip may conclude, the notion of a secure, interconnected ledger persists within the blockchain. We hope this short video has aided your understanding of the blockchain concept. Please share your feedback in the comment section below.